Hi everyone, my name is Argyrios and this is a presentation of a project as part of my attendance on CS50 Cyber Security courses.
This video has been recorded on the 4th of December 2023.
My edX account as well as my GitHub account is a-tsagkalidis. I'm going to present a zero-day vulnerability on the Zimbra Collaboration software and the cross-site scripting attacks that took place from its exploitation. This is a web security failure that affected organizations and their users across the world, and I will explain how it happened, what it caused, and how it could be prevented.
The reason I have picked up such a topic is that cross-site scripting is a very common type of cyber attack that can happen to everyone who's not aware of. It is related to the third lecture of the CS50 Cyber Security courses, where the instructor presents a whole family of code injection techniques.
But first things first, what is Zimbra? Zimbra is a collaborative email platform known for its suite of communication tools including email, calendar, file sharing, and task management. It's widely used in business environments for its open source flexibility, user-friendly interface, and strong emphasis on security. In this presentation, I will cover the next topics: how the Zimbra zero-day vulnerability was discovered and exploited, what are the causes and consequences of an XSS attack, how to prevent XSS defects and protect web applications and users. The presented zero-day vulnerability, formerly known as CVE 2023-37580, is a reflected cross-site scripting flow that affected the Zimbra platform. Cross-site scripting attacks, also known as XSS attacks, allows an adversary to inject malicious scripts into a web page and compromise the interactions that users have with the application of that page. That can lead to account impersonation, data theft, unauthorized actions, and more. The injected code is written with characters that they can be accepted from the server if there are no proper security measurements. An example that could trigger the XSS could look like this, which decodes to an HTML that contains a link to a JavaScript file that looks like this. This zero-day flow was discovered by Google's Threat Analysis Group, or TGA for short, on June 29, 2023, when their engineers detected a suspicious inbox sent to a government organization in Greece. The email contained a hyperlink to a malicious web page where an injected script could steal the user's mail data, credentials, and authentication tokens and send them to a remote server controlled by the adversaries. Zimbra pushed the hotfix to their public GitHub on July 5th, published an initial advisory on July 13th, and patched the bug about 2 weeks later. The fix was to escape the contents of the ST parameter before it was set as the value in an HTML object. However, TAG observed some extra groups of adversaries exploiting this bug in different campaigns even after the patch was released. These campaigns targeted Moldova and Tunisia on 11th of July, Vietnam on 20th of July, and Pakistan on 25th of August. It's very likely that some of the groups may have learned about the vulnerability after the hotfix was made public on GitHub. Let's see some of the factors that cause such an exploitation. Lack of proper input and output validation and sanitization in Zimbra software, which allowed the attackers to inject malicious scripts into the web pages. Use of outdated Zimbra versions, meaning lack of the latest security patches or fixes. Public known hotfix of the Zimbra vulnerability via GitHub, which enables potential adversaries to exploit it. A debatable topic regarding the use of open source versus closed source software. Low security awareness of endpoint users who clicked on the malicious links or opened the malicious emails without verifying the source of the content. The sophistication and persistence of the attackers who use different techniques and tools to exploit the vulnerability and evade detection. Let's talk about some best practices regarding XSS threat prevention that would have been taken in order to avoid such a bug or to be protected from such a threat. Use of modern web frameworks that provide built-in protection against XSS such as React or Angular. These frameworks' built-in protections steer developers to use good security practices by using templates, auto-escaping, and more. Using well-maintained libraries for HTML sanitization such as DOM Purify. HTML sanitization removes or replaces unsafe HTML elements or attributes from users' input, such as scripts and iframes. Checking for proper input and output validation and sanitization with escaping or encoding techniques against a wide list of allowed characters and values by implementing content security policy to restrict the sources and types of scripts that can be executed. Having up-to-date secure versions of web applications and servers, and applying the latest security fixes as soon as they are available. Use of antivirus software, firewalls, or other tools to prevent or detect XSS attacks on the client side. These tools can help block malicious emails, web pages, or scripts. Keeping informed users regarding cybersecurity to avoid opening malicious emails and links without verifying the source of the content. Casual users should be educated about the risks and signs of XSS and other forms of phishing attacks and how to avoid or report them. This Zimbra zero-day flow and its XSS attacks highlight the need for web security awareness. By following these recommendations and using these tools, web developers as well as users can reduce the likelihood and severity of such attacks and protect their web applications and privacy. In conclusion, we have covered the following subjects: how the Zimbra CV 2023-37580 vulnerability was discovered and exploited by groups of adversaries, what are the causes that may trigger such an XSS attack, how to prevent XSS vulnerabilities and protect web applications and users from being attacked. What we've learned from this presentation: cross-site scripting is a common and serious web security vulnerability that can have widespread and severe consequences. Developers and users need to be aware and proactive about web security and privacy and use the best practices to prevent XSS attacks. Web security is a dynamic and an evolving field that requires constant learning and collaboration among the developer communities.